Hi, Algebra 2 people.
Here we go.
So, I'm going to try and get this
embark on the practice exam
done
for
before we
chapter
have
3.
a power outage.
Okay, so
otherwise
number
I can't
1,
upload
you
it
see
to,
this fraction. It says factoring or square root method. Since I see two x terms, I'm going to do the factoring, but I also see a fraction that I don't want to have to deal with. So I am going to multiply everything here by 2. That gives me x squared minus 4x equals 12. Make sure you distribute all the way across. Then we always set our quadratic equal to 0. So minus 12 equals 0. At that point, we want to know what times what. So there's a 1 here. 1 times negative 12 goes here, because remember that's a times c. Negative 4 goes here. And in this case, it's going to be a negative 6 plus 2. Since a is 1, those are the numbers that go into the parentheses. X minus 6, x plus 2. You could always FOIL it out just to double check. And then when we set it equal to 0, we know that x will equal 6 or a negative 2. All right, so starting off friendly, now this next one, notice there's only one x term. So that's the one I'm going to do the square root method on. So you want to isolate x squared. So the first thing we're going to do is subtract 8 from both sides. That gives me 4x squared equals negative 24. Then we divide by 4. So I'm left with x squared equals a negative 6. So then we take the square root. Don't forget that plus or minus. Every quadratic has 2 answers. Unless it's a perfect square, but it still has 2 answers. So this gives me then a square root of negative 6. So the negative is going to come out as I, and the 6 stays underneath. So x is going to equal plus or minus, that's your 2 answers, I root 6. Okay? Then this next one, these are the ones I think some of you struggle with. So a is no longer 1, but we still want to set this equal to 0. So we have 2x squared minus 5x minus 3 equals 0. I still do the x here. So now a times c is a negative 6. And down here we have a negative 5. So what times what would go there? Well, I could do negative 6 plus 1. But because a is not 1, these are not the numbers that are going to go into our parenthesis. So what we're going to do is we know that negative 6 plus 1 equals a negative 5, so we're going to just rewrite, kind of expand our polynomial. It expands to 2x squared minus 6x plus 1x minus 3 equals 0. So all we did was use these middle terms to rewrite negative 5 because we made it that way. Now we do what's called factor by grouping. So I look at what's common to the first 2 terms, and that's a 2x. And then what goes in the parentheses is as if you divided each term by 2x. So that's going to leave you with an x minus 3. And it's not a bad idea to just stop and quickly do a distribution mentally. 2x times x, 2x squared. 2x times negative 3, negative 6x. So we did it right. The next 2 terms, all they have in common is 1. So we actually want to represent that. So that's plus 1. Dividing each by 1 leaves me with x minus 3. And notice, this is what you want. These are both the same. That means you did everything right. And so we're going to factor one more time. We're going to pull both of those x minus 3's together. And everything that was outside the parentheses goes into its own 2x plus 1. So now we set each factor equal to 0. So this one we know is going to be x equals 3. This one, you have 2x plus 1 equals 0. So 2x will equal negative 1, and then we divide by 2. So we have x equals 3 and a negative 1/2. And don't worry, on the test I'll give you a little more space to work. Okay, this last one, let's see, we just have x squared minus 5x minus 24, so there's nothing fancy. It's already set equal to 0. So this will be a negative 24 and a negative 5. So if we have a negative 8 plus 3, that would multiply to a negative 24, but add to a negative 5. Since a was 1, those are the numbers that go in your parenthesis. And again, you can always FOIL this through to make sure it actually works if you have time, but it does work. So setting each factor equal to 0, x will equal 8 and a negative 3. All right, so there's your factoring portion of the exam. Now we're going to do completing the square, and the process matters, so that's what we're looking for. So I'll kind of write it over here on the side again. So remember, you're going to isolate the x terms. So that means I'm going to have x squared minus 10x, and I like to have a little placeholder, equals, add 7 to the both sides, plus blank. So the x terms are on one side, constants are on another. Next thing is we take b, the middle term, half of the middle term squared, and it gets added to both sides. So this is going to give me negative 10 over 2 squared, gets added here and here. So that's negative 5 squared is 25. And I like to write that negative b over 2 because when you go to factor this, which is what you want to do now, don't take a square root. We have to finish completing the square. We just made a perfect square. And you don't really have to think about how to factor it because it's always going to be x and then whatever that middle term was. So since it's a negative 5, this will become x minus 5 equals 25 plus 7, which is 32. Now we're ready to do the square root method because we only have one squared term. So I'm going to take the square root, plus or minus the square root, off to the side. Let's see, 32 is plus or minus what times what? Since you have a calculator, it's worth finding the biggest perfect square, and in this case it's going to be 16 times 2, and square root of 16 is 4. So this becomes x minus 5 equals plus or minus 4 rad 2. Your final answer is isolating x, x equals 5 plus or minus 4 rad 2. All right, and I should have put that third step here was to complete the square. It's going to be x plus or minus, depending on whether that half that middle term was equals the other side. After that, it's the square root method. Okay, if you are struggling with that, make sure you try a few, because once you go through the process a few times, it actually goes pretty smoothly. All right, now find the discriminant, describe the number and type of roots, and then solve the equation. So this will involve the quadratic formula. But like all the others, the first thing you want to do is always set it equal to 0. So we have plus x minus 3 equals 0. So we know a is a negative 2, b is 1, c is going to be a negative 3. So to do just the discriminant, notice it has no square root on it. So b squared is going to be 1 minus 4 times a negative 2 times a negative 3. So be really careful with these negatives. The fact that I have 3 of them makes it so that this will stay negative. 1 minus 4 times 2 times 3, which will be 24. And the answer would be a negative 23. That is your discriminant. So the discriminant is what goes under the radical. So when you have a negative, that means you're going to have 2 complex roots. If you're not sure how to answer b, just go ahead and solve the equation, because you know if you have I in your final answer, that's a complex number, which is what we're going to do now. So x equals the opposite of b over 2 times a, so 2 times a negative 2, plus or minus square root of negative 23 all over 2 times negative 2, and that becomes negative over negative, so positive 1/4, plus or minus, the negative here is going to come out as I, so I have I rad 23 over 4, and I don't care whether you write it as one fraction or the 2 fractions. That I think as you're simplifying, it's more intuitive to simplify them separately. so I'm just going to leave them separate. So that was our x equals. Okay, so that was that one. Now let's see this next one. We have to set this all equal to 0. I like to keep my a positive, so I'm going to put 3x squared. I'm going to add 12x to this side, plus 1. It really doesn't matter which side you move things to. b equals 12, c equals 1. So do my discriminant first. So b squared is going to be 144 minus 4 times 3 times 1. 144 minus 12 is going to give me 132. So that is the discriminant. Since that's a nice positive number, I'm going to have 2 real roots. And now we're ready to do the quadratic formula. So x equals opposite of b over 2 times a, which is going to be 6, plus or minus square root of 132 all over 6 as well. So we want to break down 132. So let's look at the factors here. I don't have a calculator with me, so bear with me here. I know that 4 goes into 125 times plus another 8. So 25, that's going to be 33 times 4. And I think that is it. So square root of 132 equals square root of 4 times 30. So this is going to simplify to -2 plus or minus, the square root of 4 comes out as 2. So this will be 2 rad 33 over 6. Now you can't simplify under the radical, but anything on the outside can be simplified. So that's a 1 and that's a 3. So my final answer is going to be x equals -2 plus or minus rad 33 over 3. Okay, so now we are passing out of the solving a quadratic, where you're going to either factor, complete the square, square root method, quadratic formula. Those are your main tools for solving. Now we're going to work with our complex numbers. So notice this has a minus in between. So this is not FOIL. This is just adding to complex numbers. So what you want to do is you want to add like terms. So remember, it's a plus bi. There's a real part, there's an imaginary part. So what I like to do is distribute that negative. So what I really have here is a -6, make that positive, plus 8i. So I already distributed the negative, so I can now add -6. So I line up my like terms. 4 minus 6 is a -2. 12 plus 8 is 20i. -2 plus 20i. Okay, now we see the two parentheses are touching. There's no plus or minus between them. That is going to be FOIL. So the first terms will be 7 times 3. The outer terms, 7 times a -6, so minus 42i. Inner terms, plus 12i. Usually I'd write it underneath, but I didn't give you guys a lot of space on this. And then the last terms, 4 times a -6 is -24i squared. You will never give us an answer with an I squared in it, because remember, I squared equals -1. So what it does is it changes the sign of whatever comes right in front and then goes away. So you can always add your first and your last term. That's going to give me 45. And you can always add together the oi in FOIL. So -42 plus 12 is going to be a -30i. All right, now this next part is also all about combining like terms. So remember, you have a plus bi equals a plus bi. In order for those two expressions to be equal, the real part has to equal the real part. So you have -3x equals 9, divide by the -3, so you have x equals a -3. So that would make the real part equal the real part. Now we set the imaginary, the 4, equal to the 2y. You don't have to include the I just because it's going to cancel anyway. So 4 equals 2y. Make sure if there was a negative in front of those, you include the negative. And then that means when we divide by 2, that y is going to equal 2. All right, on to the next page. So I included number 11 because that's the kind of problem you'll get on the ACT or the SAT. They can't test you on completing the square, but this is how they can test that you understand the process. So if I was going to create a perfect square, remember you always take half the middle term. So the middle term's -5 divided by 2, and you square it. That'll give you your C value. So when you square that, that's -5 over 2 times -5 over 2. So you're squaring both the top and the bottom. That's going to give you 25/4, which gives you answer D. Okay? And this next one is just more practice with foiling, but now at least you have the multiple choice to kind of guide you with your answer. So first terms will give me 3. Outer term is going to be -4i. Inner term is now +6i. Now I've got room to write it correctly. And this last term, -8i squared. Remember, I squared, what it does is change the sign in front and then goes away. So 3 plus 8 would give me 11. -4 plus 6 is going to give me 2i, and that gives me the answer E. Notice some people might have given A, but that still has, I squared is not considered the simplification. Now, number 12, I told my class that this is not going to be on the test because it does come up again in the next chapter, and so I would save testing it for then. But it is still good practice working with imaginary numbers or complex numbers. So in order to get rid of the I in the denominator, you have to multiply top and bottom by the conjugate, which is the same thing what you have, but the opposite sign in between. So this becomes 4 plus 2i and 4 plus 2i. So on the bottom, you don't have to really FOIL this out, because when you multiply conjugates, the simplification is you get a squared plus b squared. If you don't believe me, then by all means FOIL it out, but you will lose your middle term because it's being added and subtracted away. And instead of a squared minus b squared, the I squared turns it into a squared plus b squared. So maybe I will FOIL it out just to show you that this is in fact true. But 4 squared is 16, 2 squared is 4, so my denominator is going to end up being 20. And if you don't believe me, let's do it. 4 times 4 is 16. Then I have plus 8i, and then we get minus 8i, so there goes your middle term. And then minus 4i squared, but the I squared makes that positive. So we had 16 plus 4. On top, I just have to distribute. So this is going to be 12i plus 6i squared. Again, this is going to go away by making that positive a negative. And we can then combine our like terms. So 6, so this is actually a -6, because you always want to put your real first, plus 12i. Now, to simplify this, please be careful because both of these, everyone is even. So I'm going to actually show exactly what we're doing. I'm factoring a 2 out of the top and the bottom. So the bottom is 2 times 10. The top is 2 times -3 plus 4i. 2's will cancel, and that gives you your final answer. -3 plus 4i over 10. Okay, so now we have the rectangle problem. So from here on out, if you do get a decimal, that's okay. I believe in the practice exam 1, this is factorable, but in the second one it isn't, so I can't make any promises. So the area of a rectangle is 250 square inches. So area is 250. The length is 5 more than twice 2 times the width. So I'm going to call the width x. So this is 2x plus 5, or 5 plus 2x. 5 more than twice the width. And then we know that area is base times height. or length times width, it all is the same. So here we get 250 equals x times 2x plus 5. So you're going to end up with a quadratic. So I'm going to have 0 equals 2x squared plus 5x minus 250. And this is actually factorable, but I'm going to pause this for a second because I don't remember how. Okay, so remember we have a times c. So a times c is going to be negative 500. Middle term is 5. And so I was just playing with the factors, and it looks like if I have a 25 minus 20, that would add up to 5 and actually multiplies to negative 500. So remember, these are not the numbers that go in. Again, you're also welcome to use quadratic formula on this. I'm kind of running out of space here, so I'm going to do my little double rainbow method. So the way that works, I know I'm going to have a 2x and an x. That's the only way I can get 2x squared, my first term. And when I look at these two factors over here, 2 only goes into one of them. It goes into negative 20, which means 25 goes on the other little what I call double rainbow. So 2 times what is a negative 20? That's going to be minus 10. And then this is a 1 in front of this x. 1 times what is 25? So it would factor that way, and I'd get x equals negative 25 halves, or a positive 10. And since a length or a width can't be negative, we throw that out. So x is 10, but that's not what it asked for. It asked for the length of the rectangle. So 2 times 10 plus 5 means that the length is going to be 25 inches. All right. And again, you could have used the quadratic formula on that one as well, and you would get the integer answers. All right, now we have our projectile problems. The height in y in feet of a basketball t seconds after it's thrown could be modeled by this function. So remember that this is your gravity, this is your initial velocity, and this is your initial height. So find the maximum height of the basketball. So in this case, we know the basketball started at 2 and it's going up. So what they're asking us to find is the vertex, but a specific part of the vertex. So remember, to find the time it gets there is opposite of b over 2a, and then after you plug that in, that gives you the maximum height. So it's going to be the y value. Okay, so let's do this. So opposite of b over 2a, that solves for the t, is going to be negative 32 over 2 times negative 16, which is also negative 32, so it's a very friendly 1. So at 1 second, it hits its maximum height. That maximum height is negative 16 times 1 squared plus 32 times 1. So we're plugging it back into the equation. Negative 16 plus 32 is 16 plus 2 is 18. So the maximum will be 18 feet. All right, now it tells us the basketball is caught in its descent when it is 7 feet above the ground. How long is it in the air? So 7 is going to equal, we set our projectile motion equal to the 7 feet, and then we are going to set this quadratic equal to 0. So negative 16t squared plus 32t, 2 minus 7, so this will become a minus 5. All right, now these are definitely going to be quadratic formula problems, but what I always like to do is I still am going to do my discriminant first because it makes it a little bit easier to work with. So b squared, and I'm going to do this on my calculator. So 32 squared minus 4 times my a value is a negative 16 times c, which is 2. That is going to give me a lovely 1152. So then we're going to put this all into our quadratic. So x equals, and I do it twice because you're going to have to enter this in your calculator twice. So the opposite of b, which is negative 32 over, and I'm going to do it all at once, plus or minus square root of 1152, all over 2 times a, which is a negative 32. Down here, whoops, sorry, I made a mistake there. That's exactly what I didn't want to do. I want to do these separately. So I'll do one of them as a plus, and negative 32 minus 1152 over negative 32. So now, again, I talked about if you just enter the numerator, and when you're done with that, hit enter, then divide it by negative 32. Otherwise, you're only going to be dividing the radical by negative 32, unless you put the whole numerator in your parentheses. Whatever works. So long as you can get, I'm going to give you the answer, and if you are good at getting that, then you're doing it right. So I get 1.9 divided by negative 32. So this top answer gives me a negative 0.06. And we know a negative answer is not going to work because we're talking time. So this next one, negative 32 minus the square root 1152. And then we divide by negative 32. This one is going to give me 2.06. So it is in the air for 2.06 seconds before he catches it 7 feet above the ground. All right, now also realize in the last question here, it is a projectile, and if you aren't sure of what the structure is, just look at the last problem. So you know it's always going to be y equals or f of x equals or h of t equals, however you want to write that, negative 16t squared. That's just your gravitational constant. The juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground, so that's going to be your h naught, and has an initial velocity of 30 feet per second, and that's positive because it's going up in the air. So that's your initial velocity. So we have plus 30t plus 4. That's your equation. And again, it's modeled also in the previous problem. Same structure. Okay, how long is the ball in the air if the juggler catches it when it falls back to a height of 3 feet? So again, how does this look? It originally is at 4 feet, and it goes up in the air, and when it gets back to 3 feet, that's when it's going to get caught. So you're going to set 3 equal to negative 16t squared plus 30t plus 4, and we want to set that equal to 0, plus 30t plus, now I'm subtracting 3 from both sides, so that'll be plus 1. And again, we're going to have to do the quadratic formula, so I'm going to do my discriminant first. And you'll have to excuse me, but I'm just going to do this on the calculator. So we have 30 squared minus 4 times negative 16 times the c value, which is just 1. And that's going to give me 964. So now we do our quadratic. X equals the opposite of b plus square root of 964 all over 2 times negative 16. And we also are going to look at if it's negative 3 minus 964 all over negative 32. And let's see what these two answers give us. So negative 30 plus second square root 964, enter, divided by negative 32. This one gives us that negative answer that we don't want, so we are going to throw that one out. Sometimes you get 2 positive answers, and usually then you want the second one because you want the ball as it's coming down. Minus second square root 964, enter, divided by negative 32. This one gives us an acceptable 1.91 seconds. Always try and give 2 decimal places on these decimal problems. All right, I hope that helps.